In this video, we look at how we can find the Cartesian equation 11 part 3 of the standard graph tutorial. Again, as in 11 part 2, from sine square theta plus cos square theta equals to 1, we know that if we divide throughout by sine square theta, we'll get 1 plus cotangent square theta equals to cosecant square theta. From our parametric equations, we know that cosecant theta is x over 2, whereas cotangent theta is y over 3. So when we substitute this back into our trigo identity, we find that we have 1 plus y over 3 square equals to x over 2 square. So this gives us the equation x squared over 2 minus y squared over 3 square equals to 1. Again, this is the equation of the hyperbola that looks like this and the two sides like that. Noting that the value below x squared is 2 square, it tells us that over here it should be negative 2 and here should be 2. Because again, the distances here are actually 2. We also need to consider the restrictions due to the restriction of the parameter value theta. So we do not take the whole graph here. We need to limit the graph according to the parameter range. We consider that when theta is between 0 to pi, we recall that in secondary school, it means that between theta equals to 0 and theta equals to pi, we are looking at the first and second quadrant. CAST tells us that first two quadrant, sign is definitely positive. Now, for x, we have 2 cosecant theta. We know that that is same as 2 over sine theta. 2 over sine theta here. Now, we know that the first two quadrant, in the first two quadrant, the sign is positive. So it means that x must be positive. Over here, 3 cotangent theta. So it's actually 3 over tangent theta. Now, we know that for the first quadrant, when theta is between 0 to pi over 2, tangent theta will be positive, so y will be positive. Because denominator here positive and numerator is positive. But for theta between pi over 2 and pi, which is the second quadrant, we know that tangent is negative, so the y will be negative. So actually the y can be both positive and negative for this range of values of theta. Thus, when we write down our Cartesian equation for this part, we know that the part of the graph that we are considering will be when x is positive and when y can be positive or negative. So it means that, in other words, it's talking about this portion of the graph where x is positive and y can be both positive and negative. So if we look at this, we know the range is x more than or equals to 2 and your y can be any real values. So therefore, when we write down our Cartesian equation, we should be writing it down as x squared over 2 square minus y squared over 3 square equals to 1, following which we will state our restriction for our values of x as x bigger than or equals to 2, y can be all real values. Thank you.